Hey guys, welcome back to my channel. I hope you are all doing fine and I wish you a happy new year. So, in this video, we'll be talking about equilibrium, which is the lecture 5 of module 1 of engineering mechanics. So, we'll just have a brief idea of what is equilibrium, equilibrium of body, and so on. Then we'll be basically doing examples and problems and assignment questions from this chapter. Okay, so let's get started. So what is a equilibrium? A force which is equal, opposite and collinear, that means parallel to the resultant force, is called equilibrium. Two concurrent forces can be in equilibrium if they are or the resultant is equal to zero. A body can be in equilibrium if it is at rest or moving with a constant velocity. It's just the Newton's first law saying that it can be at rest or moving with a constant velocity. Okay, so in these cases we can say the body is at equilibrium. Then equilibrium of a body, when the resultant of all the forces is zero, then the body is in equilibrium. In graphical terms, it means force polygon closes. Force polygon is nothing but when these forces are kept in the form of a polygon, then this force polygon closes. That means this resultant will become zero. Then we have equilibrium law for two forces can be in equilibrium only if they are in equal in magnitude and opposite in direction and collinear in action. Okay, so what are the principles? We have some principles of equilibrium. We have different cases. In the case if there are two forces, then it is acted upon by two bodies. Then three force principle. That means like in two force principle, there will be two forces in opposite directions that should be in equal in magnitude, opposite in direction, and collinear. Similarly, if there are three forces, the resultant of two forces must be equal and opposite to the opposite and collinear. And similarly, we have four force principle. That means resultant of two forces must be equal and opposite and collinear in action to the resultant of the other two. I'll just show you an example. I'll just fastly show you an example. See, if we are given a forces like this, we have force F1, F2, F3, and F4, and the four force principle is saying that the resultant of this, that means this will be like this, and the resultant of the other force like this. Then we'll take the equilibrium. Okay, that is how we are doing. We are just not taking the first one, taking the other three. We are taking the resultant of the first two forces and then the resultant of the second two forces. Okay, now let us talk about law of superposition. The action of a body, action of a given system of forces on a rigid body will in no way be changed if we add or subtract from them another system of forces in action. It's nothing but equilibrium. Then we have some types of force. We have applied force, force applied externally on body. Then we have non-applied forces. We have self weight, which is W, which is equal to mg. Every body is subjected to a gravitational acceleration downwards along the center of gravity. Then we have reactions, self-adjusting forces developed by the other bodies which come in contact with the body under consideration. Surface of contact is smooth, means direction of reaction. The law of action and reaction. Any pressure on support cause equal and opposite pressure from the others the support so that the action and reaction are two equal and opposite forces. Then we have free body. Free body, this is a very important concept. Free body, we'll be doing some examples of free body. If we have a solid understanding of free body, only then we'll be able to do the problems in other cases, because there will be a lot of problems coming our way. So here, a free body. What is a free body? Free body is a body not connected with other bodies and which form any which from any given position can be displaced in any direction. That means it is completely independent of the environment which is it is. It's just the body and the reactions and the self weight and the other forces happening on that body itself, and the rest of everything are ignored. So free body is a sketch of the isolated body which shows the external forces on the body and the reactions exerted on it by the removed elements. Okay, I hope you understood. I'll show you an example here. So here we need to draw the free body diagram. We need to draw the free body diagram. Once again, I'll just pin this one. Okay. We need to draw the free body diagram of the following figure. What the concept is saying is that it is a sketch of the isolated body. So we need to draw the circle first, and not this ground where it is staying, and then we should draw the forces acting on it. So what are the forces here? There is just the normal force acting here and the weight of the body downwards. So we here will be having a W this side, and here will be having a normal reaction this side. I hope this is the answer here. So here we have the W here, which is downwards, and the reaction force on the upper side. So this is the way we are doing free body diagram. We are just drawing the diagram of the object and the forces acting on it. Okay, acting on it and the forces which is acted by it. Okay, now let us move to the second example. Here we have the free we need to draw the free body diagram of the following figure. So here we have wall, here we have some kind of a sphere, or we can consider it as a circle, and sorry, and I just hate that part. And then we here there is a tensile force uh, which is holding this circle like this in this position. So what are the forces here that we should visualize that? So there will be a tensile force in this manner, yes, and then this is the tension force. Then there will be a normal reaction, the reaction, or else if this wall, consider if there is no wall like this, then this circle will be at the center, so there will be a reaction in this in this side. Okay, so we'll just draw that also. Then there will be a self weight of this circle, that means the force due to its weight and gravity which will be acting downwards. Okay, so these are the forces. Now what we need to do is that we just need to isolate the body and remove all the constraints, or remove all the other things. So here we have the resultant, we have no, we have the reaction, then we have the tension, then we have W. Okay, now let us move to the third one. So in this case we need to draw the free body diagram of the following figure. So here we are given a ladder. Consider it as a ladder, because this is the same thing which we'll be doing in the coming problems, because we'll be having ladder problems. So it will be just the same thing, and we will be needing to change this into components and find the forces like that. So pause this video and do do it, try brainstorming and come back. Okay, so here we are given we should draw the free body diagram of this. So what is this? It's just a ladder here. Then after drawing the ladder, here we have a 600 Newton force. We'll just draw the 600 Newton force like this. Then we have a force like this P. Is that it? Is there any other forces? Consider if there is no wall here, what will happen? What will happen? The ladder will come down. So this wall is acting as a support to make it stand there like that. So there is a reaction force like this. Okay, so these are the three forces acting. Then of course there is one more force. What are the that force? What is that force? It is the W force which is acting downwards. Okay, so these are the forces acting. So for if you are drawing this diagram, here we have, then we have the reaction force of this from the ground. Also we have the reaction force also from the ground. So we have the reaction force, then we have the friction force, then we have the W force, then we have the weight of the man, then we have the reaction force from the wall to the ladder. So these are the forces acting on the body, acting on ladder this ladder. Okay, so in this problem we need to draw the free body diagram of the following figure. So this is our figure. So what do you think? What do you think are the forces? Just tell me. Just pause the video. Find it. We need to find the free body diagram of this figure. Okay. We need to draw the free body diagram of this figure. So I think you must have got it by now. So what are the forces? Tell me. So these are the forces. So there will be a weight of this circle here, then the reaction force in this direction, and the normal reaction from the ground. Okay, so these are the directions. So let us move to the next example. So assignment question 5. Now I'll just end this video here because this video is getting lengthy. I'll just do from us. There are some more questions like this, and then there will be a tension problem also. So what I'll do is that I'll stop here. I'll do the next video in part 2 of this. Okay. So I hope you understood what I taught you today. Do consider subscribing to my channel, and if you didn't like my video, please comment what I should do to improve my videos. Okay, so thank you for watching. I'll see you in the next one. Happy learning.